Development occurs in an uncertain world, right? As I mentioned earlier, it's research and development in a time of rapid technological change. Alan Ward, one of the lean authors and thought leaders, aggressively evaluate alternatives, converge specifications in a solution set. So what happens? Let's look at this cone of uncertainty out here, right? We're early in. This is time goes this way, and later on I'm going to end up with something pretty cool. Okay, but how do I want to approach the problem? I want to approach the problem by recognizing that I don't know everything here. It's not possible. I have little knowledge of all the things that are going to happen to me in the future that affect my understanding of the system. And if at all possible, requirements must be flexible to economic design choices. Let me give you an example. What's the difference in cost between 99.9 reliability of a site and 99.999? Is it 10 to 1? Might be 100 to 1. Getting that extra one might mean the whole system has to be redundant. It could be that this is the right economic choice, or maybe it's 99.7. That's just down, that system would be down a few hours a year. Is that good? No. How much do I want to invest to make sure I never suffer the 2-hour shortage or even the 1-minute shortage? Okay, that depends on the environment. So we need to understand that economics affect these decisions. It's easy to say 99.9% or 5 nines reliability. Really hard to build it. Preservation of options improves economic results. This is the important thing. So long as I have options, I'm not yet committed to a course of action that turns out not to be particularly helpful in that process. So what does that mean? It means that we want to think about applying a set-based approach. And a set-based approach doesn't look like this, right? This is a point-based approach. I found something, I made an adjustment, I got here, and it's the wrong dang thing, right? I had false positive certainty. It didn't really work that way at all. Instead, we want to try a different model. And in this model, we want to have some design options present. Now, some of those can be real things I develop. Others are just alternatives. Let me give you a really simple, stupid example. We're a company. We deliver stuff. When we delivered 4.0, there were reasons why we had to pick a date certain. It wasn't that we weren't agile. It wasn't that, the system only lent itself to being done at that date. It was a date certain because of the ecosystem around us. The ecosystem around us needed to know the date. It couldn't be ambiguous. It might be A or it might be B. So we had to pick that date. When we picked that date, we then said, wow, we have all this work to do. How can we guarantee that date? And we had a couple of options. Now, I'll name two just in the context of our website. One is that earlier I showed you that we have abstracts, right, and details. One of the options that we kept was that if necessary, on some new elements, we can ship with only abstracts. That didn't cost us anything. Okay, and we didn't go in and write a bunch of articles that had abstracts, so that was just a mental notion that said, I can do it this way. Another option that we had was we came up with an entire new design for the site itself. Well, we kept the old design alive. So during our development, we kept that design moving, right? Actually, all the way to here. Because if the new design wasn't done in time, we could use the old one. So yes, we made a small investment, right? We made an economic choice that says, let's keep the old design alive while the new one is developed, right? And make literally a branch because we have to ship on that day. So there's an example of one design option, which is just, we'll only go with abstracts and recover later, that costs nothing, and another design option, which is that, wow, we're going to keep our old design alive and implement the new system on the old design, and that costs something. And at each learning point, we revisited that. So it doesn't have to be that I built 2 versions of the satellite or 2 versions of the application, or I run on 2 databases, although it could be that. It has to be whatever it has to be such that you have a way to achieve real reliability. Sometimes fixed date, sometimes not. Maybe it's not a fixed date. I still want as much flexibility as I have, as long as I can have it. And that's called a set-based approach to development. Now, I'll also tell you that if you read Reinertson's work, which we'll talk about in a second, he says, sometimes the optimum number of sets is 1. And that could be true. That wasn't the case in our case. We had 1, 2 significant design options that we used to make sure that we met our deadline. So if I'm shipping a satellite or I have to be in clinical trials at a certain date because that's when I have the patients, I have to have some design flexibility, because if I don't have design flexibility, even though I'm agile, I have to execute everything perfect. Well, being agile basically says it's not going to be perfect, right? So that's not going to be the outcome. The outcome has to be a whole set of interactions that end up in the right place.